The answer might surprise you. It's not just a matter of distance, but a complex dance of orbits, technology, and celestial mechanics. You see, Earth and Mars aren't just sitting still in space, they're constantly orbiting the Sun, each at its own pace. Earth, being closer to the Sun, zips around our star in, as we all know, about 365 days. Mars, on the other hand, takes a more leisurely 687 days to complete its orbit. Think of it like two runners on a track, one sprinting and the other jogging. The distance between them is always changing. Sometimes they're closer to each other and sometimes they're farther apart. This ever-changing distance is crucial to understanding how long it takes to travel to Mars. At their closest point, when Earth and Mars are aligned on the same side of the Sun, they're only about 33.9 million miles apart. But here's the catch. This perfect alignment is super rare. The closest we've ever recorded ourselves to Mars happened in 2003 when the two planets were 34.8 million miles apart. Most of the time, the distance is much greater. At their farthest, when they're on opposite sides of the Sun, Earth and Mars can be a staggering 250 million miles apart. On average, the distance between Earth and Mars is about 140 million miles. That's still a mind-boggling distance, roughly equivalent to driving around the Earth 5,880 times. So the first hurdle in planning a trip to Mars is timing. We need to launch when Earth and Mars are relatively close to minimize travel time and fuel consumption. These ideal launch windows occur roughly every 26 months, so timing is everything. But even when Mars is at its closest, it's not a simple straight shot. Space travel isn't like driving down a highway. You can't just point your spaceship in the right direction and floor it. The most efficient path to Mars is a curved trajectory called a Hohmann transfer orbit. This orbit takes advantage of the planet's motion around the Sun. It's like swinging on a vine to reach another branch. You need to time your release just right to make the jump. Similarly, a spacecraft on a Hohmann transfer orbit uses the planet's gravity to slingshot itself toward Mars, saving fuel and time in the process. But our current workhorses for space travel are chemical rockets. These powerful machines propel spacecraft to incredible speeds, but they are also limited by the amount of fuel they can carry. With our current chemical rocket technology, a one-way trip to Mars typically takes about 6 to 9 months. That's a long time to be cooped up in a spacecraft, even with all the modern comforts and amenities we can cram in there. Astronauts on a Mars mission would face a unique set of challenges, from the physical effects of microgravity to the psychological strain of isolation and confinement. Scientists and engineers are constantly pushing the boundaries of space travel, searching for ways to make the journey to Mars faster and more efficient. There are several promising technologies on the horizon that could revolutionize how we travel through space. Ion drives, for instance, use electrically charged particles to generate thrust. They're incredibly efficient, but they produce very low thrust, as it would take longer to accelerate to high speeds. Think of them like a tortoise in the cosmic race, slow and steady, but with incredible endurance. Nuclear propulsion, on the other hand, harnesses the power of nuclear reactions to generate thrust. It offers a significant boost in speed and efficiency compared to chemical rockets, but it also comes with a safety and environmental concern. Imagine a rocket with a nuclear reactor on board. It's a powerful beast, but it needs to be handled with care. And then there are solar sails, which harness the momentum of photons from the sun to propel a spacecraft. They're like cosmic sailboats, gliding through space on the gentle breeze of sunlight. While they offer the potential for extremely fast travel, they're still in the early stages of development. While those futuristic propulsion systems sound amazing, for now we're still bound by the laws of physics and the limitations of our current technology. So, what does that mean for real-life Mars missions? First of all, we can't just blast off to Mars whenever the mood strikes. We have to wait for those special launch windows, which, like I mentioned, happen roughly every 26 months when Earth and Mars are favorably aligned. Even with these launch windows, the precise time can fluctuate depending on the specific position of Earth and Mars. Sometimes the alignment is ideal and the journey is slightly shorter. Other times the planets are a bit farther apart, adding a few weeks to the trip. Just take a look at how long our past missions took. Mariner 4, launched in 1964, took a leisurely 228 days, around 7.5 months, to reach Mars, capturing the first close-up images of another planet. Mariner 9, launched in 1971, arrived in 168 days, about 5.5 months, and became the first spacecraft to orbit Mars, mapping its entire surface. Viking 1, launched in 1975, took a longer journey of 304 days, roughly 10 months, but it made history by being the first spacecraft to land successfully on Mars. These early missions, with their extended travel times, highlight the challenges of interplanetary travel using conventional propulsion methods. However, they also paved the way for more ambitious endeavors. Today, we have seen active orbiters circling Mars, like the Mars Reconnaissance Orbiter, MAVEN, and the European Space Agency's Mars Express. These robotic sentinels have mapped the Martian surface in stunning detail, revealing evidence of ancient riverbeds, towering volcanoes, and vast polar ice caps. They've also studied the planet's atmosphere and climate, giving us a glimpse into its past and present. Then there are the landers, like NASA's InSight and the Phoenix Mars lander. These intrepid explorers have touched down on Martian surface, conducting experiments to study the planet's interior, search for signs of water, ice, and analyze soil composition. And of course, we can't forget the rovers, the mechanical marvels that have roamed the Martian landscape, from the tiny Sojourner to the car-sized Curiosity and Perseverance. These robotic explorers have captured our imagination, and their incredible journeys and groundbreaking discoveries. They've sent back breathtaking images of alien landscapes, analyzed rocks and materials, and even detected organic molecules, raising intriguing questions about the possibility of past or present life on Mars. These orbiters, while unmanned, present the culmination of decades of technological advancements and scientific curiosity. They remind us that even with the current limitations of space travel, we can still achieve extraordinary things. But let's not forget the human element. Sending humans to Mars is a whole different ballgame. It's not just about getting there, it's about ensuring the astronauts' safety and well-being throughout the long and arduous journey. Imagine spending months confined to a cramped spacecraft, hurtling through the vast emptiness of space. You're millions of miles away from home with no quick return trip possible. The physical and psychological challenges of such a journey are immense, and the microgravity environment of space, the human body undergoes significant changes. Muscles weaken, bones lose density, and the cardiovascular system adapts to the lack of gravity. To combat these effects, astronauts on a Mars mission would need to exercise for hours each day using specialized equipment designed for space. But it's not just physical health that's at stake. Long-duration spaceflight also takes a toll on the mind. Isolation, confinement, and constant stress of living in a hostile environment can lead to psychological changes like anxiety, depression, and sleep disturbances. Astronauts would need to be carefully selected to train to withstand the mental rigors of the journey. They would need strong coping mechanisms, effective communication skills, and the ability to work as a cohesive team even in the face of adversity. The psychological challenges of a Mars mission are perhaps best exemplified by the Mars 500 experiment, where a crew of 6 men spent 520 days in a simulated spacecraft, isolated from the outside world. The experiment provided valuable insight into the psychological effects of long-duration spaceflight and the importance of crew cohesion and support. Now, considering everything currently with our existing technology and the trusty Hohmann transfer orbit, the average travel time to Mars is about 9 months. That's roughly the same amount of time it takes to grow a human being. But of course, those sci-fi movies we all love paint a different picture, with astronauts zipping to Mars in a matter of days or weeks. While those warp drives and hyperspace jumps might be thrilling on the big screen, they're still firmly in the realm of science fiction. The reality is, a journey to Mars is a monumental undertaking, a testament to human ingenuity and perseverance. It's not a weekend getaway, but a long and challenging voyage that pushes the boundaries of what we can achieve. However, scientists and engineers are already developing solutions. From inflatable habitats and 3D printed structures to advanced life support systems and resource extraction technologies, we're making strides towards creating a sustainable presence on Mars. They're planning a future where humans live and work on Mars, conducting scientific research, exploring the planet's vast landscapes, and perhaps even terraforming it to make it more habitable. It's a future where humanity becomes a multi-planetary species, expanding our reach beyond Earth and ensuring our long-term survival. While this vision might seem like science fiction, it's a vision that's rooted in science and fueled by human ingenuity. And with each technological advancement, we're one step closer to making it a reality.